Uh, Hello, Copenhagen. Good. Well, I guess it's noon for you. I'm very sad that I'm not able to be there today. And hopefully this presentation will go okay. I can't really hear you all, but I can kind of see you. So hopefully something awkward doesn't happen and I just kind of continue continue stupidly onwards. Yeah, I'm going to talk about Deno. It's a project I've been working on for the past couple of years. And yeah, let's get into it. I think we can all agree that the web has become the medium of human information, and that the web will still be here some years from now, maybe 5 years from now, if not 10 or 20. This wasn't always the case. You know, back in, let's say, 2010, it was maybe looking like mobile apps were potentially going to replace the web. But I think we can say with confidence now in 2022 that the web is here to stay. You know, I don't know how far out we can say that, but you know, at least a couple of years. And that's actually a lot more than you can say about a lot of other technologies. Because we can say that the web will be here, the protocols that make up the web will be here. That is HTTP, HTML, CSS, and JavaScript. JavaScript is inherently tied to the web. And therefore, I think it's clear that JavaScript will still be important many years from now. And because of this, JavaScript has in some ways become the default scripting language, if not the default programming language overall. And yet so much of the tooling and libraries around JavaScript remain hopelessly sophomoric. This language demands more of our attention and better tooling and better infrastructure around it, because we're going to be living with it for quite a long time. This is not a language that anybody chose and decided was something that we should build the society on. It's this organic thing, much like the web itself, that has had humble beginnings and kind of grown into the thing it is. I'm interested in building on this. So I just want to, in the abstract, describe what I see as my ideal software stack, and naturally how this relates to JavaScript. So my dream stack is one that reduces boilerplate. Ideally, very small apps can be defined in a single file. There's so much to the modern technology stack for servers or other software. You build on top of public clouds, which have vast amounts of infrastructure. You build on top of languages, runtimes, libraries. Because we're sitting on top of so much stuff, it's important that we're able to focus on the problem that we're solving and not have to deal with a bunch of superfluous configuration or boilerplate. My dream stack would use JavaScript, the universal scripting language. I think scripting languages are not appropriate for every use case. Indeed, in my day-to-day life, I am using Rust mostly, but that's because I work on a runtime. You know, I think if you're working on an operating system or a database or a scripting language runtime, I think it makes sense to drop down to native languages like C++ or Rust or Go. But I think for the vast majority of business logic out there, scripting languages make a lot of sense. It's kind of the most terse way of expressing an idea. And most things most problems that we encounter as software engineers aren't actually computationally bound. They're engineering time bound, actually. And because of that, I would reach for a scripting language when it comes to many different problems. When I built Node, it was all about being able to do asynchronous I/O. I think that is quite important still, but these days it is table stakes. So optimal HTTP server performance, being able to handle many concurrent clients, thousands of concurrent clients is table stakes these days in 2022. But of course, this is, should be said. We want it to be performant. And I think the development tools like code formatting or linting or integration with your editor, this should all be defined, and it shouldn't be something that you need to choose one by one and spend a lot of time on. I think development tools have progressed a lot in recent years, and it's important that those things just work. I think it's also important to say that the Dream Stack kind of extends into the cloud, because if you're writing servers, you must think about where these servers are going to be deployed to. There is no world in which you're going to be running, like I did when I was a teenager, have a desktop computer in your closet that is actually serving your website. Not only is that not optimal, it's not cost effective. It goes down. It's slow. We need to think about how our software stacks, how our server software extends into the cloud. This infrastructure must be thought about. And so my dream stack would be serverless. That it's free for low traffic demo apps. If it's not getting any requests, it shouldn't be costing me anything. And it's completely managed. It's just going to stay up. And it should scale, of course. If for whatever reason the site gets on Hacker News or there's a flash sale on my e-commerce site, it should be able to scale to handle that load. An important latency optimization is being able to run your application server close to the users, that is geographically close. We are the era where you have a single application server in US East and maybe a CDN around that is I think over. You really need your application running everywhere. And I think this is kind of the new frontier of server development. That last bit of latency counts, especially if you're a user in Australia. You don't need to be making speed of light bound requests out to US East or wherever the application server is hosted. We should be able to respond to requests in a local data center. Cold starts must be fast, and it shouldn't have any config, or as little config as necessary. And I'm thinking about all of the terraforming that is necessary to interact with GCP or AWS these days. It can be a lot, actually. And I think this can all be done quite a bit better. So Deno is JavaScript for professional software engineers. This is my attempt to implement this stack. It is focused on being simple, secure, and optimal. I'm going to jump into some demos here. There's a lot of words, but so it's simple because it has a bunch of this tooling built into it. So For example, TypeScript comes out of the box. This is very important for building complex applications. Type annotations in JavaScript, I think are standard practice at this point, but getting this all set up can be quite difficult in Node. This all works quite well in Deno. It has common tooling built in. It has a standard library. You can pull in third-party modules from HTTPS or NPM. This is a new feature, which I'll show you in a second. There's a little code sample there. You can use Deno compile to build all of your dependencies into an executable and kind of a self-contained binary. Browser knowledge transfers easily because Deno does a lot of hard work to adhere to browser APIs. So although Deno is server-side JavaScript, it feels very much like a browser. Let me show you this example here. So I've actually got this listed up here, and hopefully you all can see that. So what you can do in Deno, and excuse my Vim here, I'm not acquainted with the new VS Code stuff, but in Deno you can pull in any NPM module just using this NPM specifier, NPM : specifier. And here we're pulling in Express, which is kind of a legacy Node library. And we're pulling it in at version 4. It has kind of semver semantics, and you do the typical Express hello world here. So you construct an app, and when somebody requests / you respond with hello world. You listen on port 3000, and then you print that you're listening. Let's try it out. So Deno run, because of the NPM specifier, I need to give unstable. We're going to be stabilizing this in probably a month or so. So a little bit of a preview feature here. And you can run Express. I'm going to talk about security in a second, but we need to allow network access, and we need to allow read access here to the bot. Actually, no, I don't think we need that. We definitely need network access. So ignore that. I'll talk about security in a second. So when I run this, it needs to go download a bunch of dependencies. Oh yes, it does need CWD access. I wonder why though. So Deno, like I said, I'll get into security in a second, but you get these kind of prompts here that say, oh, this Express program is trying to access your current working directory. Do you want to allow or deny that? I say no. It's going to crash and say permission denied. I can run it again and say yes. And I guess it also requires an environment variable called node deprecation, also yes, and trace deprecation, and actually all environment variables, which is a little unfortunate, but for some reason Express is doing that. But now we have a little server running that can respond with hello world. So again, all of this kind of summed up in a simple little file here that completely expresses what that program is trying to do. Secure, so by default, Deno runs in a sandbox, and you kind of got a hint of it with that example. Unlike in Node, you do not need to allow remote code execution to install a module. So whenever if you've used Node, you might have used NPM. And when you NPM add a module, this is literally doing remote code execution from random people on the internet. This is no good. And there have been all sorts of problems with this. Deno, of course, we're doing server-side JavaScript, and you need to interact with the operating system. But Deno at least provides these gates for you to know what this code is doing, and you can decide whether you want to allow it or not. And Deno is also written in Rust instead of C++, and so this is avoiding a whole class of memory safety bugs. We strive to make Deno optimal in every benchmark, and it helps that Deno is built on the shoulders of giants. V8, which I'm sure many of you know, originates in Denmark, in Aarhus, and Rust, both amazing pieces of software. So we're going to be publishing a comprehensive analysis of Deno's performance, but it is pretty good, and we try very hard to make it quite good. And I won't name any names, but some people like to cherry pick benchmarks here and kind of give the wrong impression of Deno. Deno is quite fast. So in this benchmark here, we're running WRK2 and using a little Hello World server with 1,000 connections, and seeing what sort of throughput we can get from Deno, and what sort of memory usage we are seeing during that benchmark. So again, watch our blog for a full benchmark suite coming out very soon. Deno is, the formatting here is not very great. I mentioned web standards. So Deno is very much like a web browser, and in kind of order of importance here, or maybe order of least surprise. These are some of the things that you can find in Deno. So global this, of course, WebAssembly comes out of the box from V8. We have web crypto, we have web workers, we have transform stream, including all sorts of interesting, if you know what that is, things like compression stream, also event target, abort controller, location. I can't see your faces, but if there's any like web aficionados in there, I hope to see some smirks as you as we kind of go down this list here. Form data, request and response, of course, fetch, window.close, local storage, and web GPU, among many other things. So we are really trying to adhere to how the browser defines JavaScript, because of course the browser is always going to be the future of JavaScript. This is, as I mentioned at the beginning, inherently tied to human infrastructure. We participate in standards organizations like TC39 and Winter CG, which is a new group that is trying to define a common server-side, common server-side JavaScript interoperability. And we work with this with Cloudflare, among others. You can read more about this at wintercg.org. What I've been describing here is a local development runtime, much like Node, but we take the pieces of Deno, and we build a product called Deno Deploy, which is really building this serverless system for really geared towards JavaScript. And so what this does is you essentially give us a function, JavaScript function, that takes a request and returns a response. potentially calls into WebAssembly, potentially imports modules. And what we can do is host this at the edge in 34 data centers worldwide. And we can do this very optimally. And so let me give a little demo of what this might look like here. So this is Deno deploy. And what we can do is I mentioned there's GitHub integration, but I'm just going to use the little playground here to toy around with something. So I'll delete this. So import serve from HTTPS Denoland std http server.ts. This is our server library, and this serve function takes a request and returns a response. And we'll just say hello. And when I click, so on the right side here, this has provisioned us a subdomain cloudy squirrel 32.deno.dev. And when I click save and deploy here, what it's doing is rolling out this code, essentially uploading this code to all of our regions. And this thing is now persisted worldwide. So the cool thing about this is that this is essentially a row in a table somewhere. It is super cheap for us to persist this forever. Responding with just hello is kind of dumb. So let me make this kind of a dynamic response. So maybe I can put the date here, for example. So I'll save and deploy it again. Again, this is full deployment. So this takes, I don't know, 5 seconds or so. But this is truly being deployed worldwide. And in the logs here, I can see Europe West 4, which presumably is some people there in the audience hitting this. Let me change the subdomain to GOTO Conf. Okay, so now we have gotoconf.deno.dev. And just to examine this a little bit, let's look at the headers. So it does HTTP2. I'm here in New York City, so I'm getting this from US East 4. And yeah, of course, every time I hit this, it is dynamically creating this response with a different date each time, right? So it's really running this JavaScript at the edge. And so maybe this seems a little trite and simple, but what I would argue is that this generalizes to arbitrarily complex sites, and we can do quite complex things. Like my blog, for example, is on this, or Deno.land is on this, or a bunch of other websites. So we can do chats and all sorts of stuff. So this is really what I mean by this dream stack. Deno deploy is kind of acts as a white label serverless system that powers, for example, Netlify edge functions or Supabase edge functions. So it is kind of behind the scenes handling quite a bit of infrastructure, quite a bit of services. So what I'd like to argue is that we're approaching a post-Unix future here. That serverless edge runtimes like Cloudflare Workers and like Deno deploy are very fast and very cheap. And the performance and simplicity achieved by using V8 isolates for multi-tenancy, the simplicity, the benefit here is coming from the fact that we're using JavaScript as kind of the container abstraction here. So for that little JavaScript function that I spun up, we didn't provision a Docker container. We're not doing any heavy processing here. This is really like opening a tab. So we push out that little bit of code to all of the servers, all of our regions worldwide, and essentially, at that point, all we need to do is kind of open a tab when a new request comes in to handle it. So it provides kind of this new container abstraction when compared to, say, Linux containers. And this allows us to do it very, very cheap. And I think my prediction is that to maximize the utility of serverless web frameworks are soon going to be built on these post-Unix primitives rather than on Unix primitives, i.e. node style systems. So to put this all together, I want to show you a web framework that we built to work with Deno called Fresh. And this is a new piece of software, and it is built to be very fast. So it renders everything just in time on the server. It doesn't ship any JavaScript to the client by default. It uses islands-based architecture for client interactivity. It automatically inlines CSS with Tailwind, has TypeScript out of the box, doesn't have any configuration. And I want to wrap up here with a little demo of this. So let me clear my screens here. So what I'm going to do is I want to compare this to Create React App. So what I'm going to do is run the Fresh install script. So fresh.deno.dev. When you do Deno run against this, it's kind of like it's Fresh's version of create React App. So my Fresh app. And on this other terminal here, what I'm going to do is do npx create. Yeah. So I'm going to do npx create React App, my React App. Okay, let's just compare these two things. This is a fair comparison. I've kind of cleared my caches beforehand. So we'll start the npx. We gotta install this. We'll give it a fair head start here. On this side, I'll start running my Deno stuff. It's downloading some of the dependencies, and it's basically done now. So we want to use Tailwind. Yes, we want to use VS Code. Okay, it's done. So I can go into my Fresh app here, and we can go Deno task start to get it running. I guess it has to install a couple of other things. And now we have something running on localhost. So let me just paste that in here. So here's the Fresh app running. By the way, Create React App still going here. And let me just edit one of the routes here. So this is the home page, and it says welcome to Fresh, you know, with some little interactivity. And we'll just say go to and save that. And of course, it auto updates. And yeah, I'd encourage you to check out what this looks like in DevTools here. I think you'll find that it is quite optimal, actually. I really wanted to compare the sizes here, but Create React App is actually still installing. And I'm running out of time with my conference talk here. So maybe I'll just du-sh my Fresh app here. Oh, maybe that guy's done. And maybe I'll do finally, okay. So, and on this side, I can do du-sh my React app. This one is 329 megabytes. This one is 84 kilobytes. So I think the point of this demo here is that there is a lot that can be optimized, and there's still a lot to do in server-side JavaScript, and the server-side infrastructure where we deploy it to in the cloud, and on the web frameworks. And we are working on that. And if you're interested in working with us, we're hiring.